Hi everyone, this is 𝗘𝗅𝗽𝗲𝗀, and today we're joined by Junchen Jiang, CEO and co-founder of Tensormesh, the company that's revolutionizing how inference is consumed with their open source project, LMCache. Junchen co-created LMCache at the University of Chicago just 2 years ago, and it has already become one of the hottest optimizing projects in AI inference today. And this week, Tensormesh just announced it raised $20 million to fix AI most expensive problem. Some of you may know it as 𝗘𝗍𝗃𝗃. At Tensormesh, they call it the big data layer of AI. Junchen, welcome, and first of all, congratulations for the announcement.
Thank you.
How are you feeling today?
I'm feeling great, and thanks for having me.
All right, Junchen, I'm going to start with just the early days. Could you tell us back to the moment before you created LMCache with your co-founders? Could you tell us what insight did you have that led you to create the project?
Sure. So it's a very nice story behind the project and also the startup itself. It all started back 3 years ago when ChatGPT barely became popular back then. And I was among one of the faculty professors in academia that was asked by their students, what can I do about this transformer thing or large language model or just GPT?
Mm-hmm.
And at the beginning, of course, I was not working on large language model research. And like many others, I was skeptical and dismissive about this at the beginning because it's just yet another popular application.
True.
And it happens many times over history, right? So why bother doing more research about this particular thing? Now, and then when I talk more to my students, it became clear that this is not yet another machine learning application or AI application. This is the first time in history that AI use case that could dominate the whole world. That everyone can have a use case about it, right? This chatbot could be used by everyone in their daily life. This is first time in history. So that was the moment where we realized this was the internet moment of the next generation. Because back in the day, 20 years ago, well, probably 30 years ago, internet had the same effect to the society where everyone realized there was something that's new that can be used by everyone. Now, AI has the same effect, right? All of a sudden, there's this new application that can be used by everyone. Mm-hmm. That creates a whole new set of problems. The communication system needs to be changed. The data management system needs to be changed. The whole system needs to be changed. There's a whole new infrastructure to be built for it. Now, where to start? Naturally, we were internet networking system researchers. So we thought, what is the data for AI? And then we realized the data for AI is really 𝗘𝗍𝗃𝗃 cache because that's how transformers or all large language models these days remember information. That's the internal representation of knowledge by these AI models. Now, once we realize that's the new data, then it becomes all natural to us. We should start building this database system. We should start building the compression system for it because the 𝗘𝗍𝗃𝗃 cache is really big. We should build the networking system for AI model to communicate with each other through 𝗘𝗍𝗃 cache or share 𝗘𝗍𝗃 cache to begin with. So we start writing papers. Okay, naturally we start writing papers. There was no commercialization plan in mind. Then after a year, we succeeded in publishing no papers about this because when I give talks about what we have been doing, all these research ideas, no one could understand it.
True.
Because industry was too busy building applications on top of ChatGPT. Research world has not been thinking about building systems for this yet. So no one could understand what we are talking about, even though we know very soon you guys are going to be craving for something like this. So back in 2024, we decided to open source our project because that's the easiest way for people to build, to first use our technique and then build on top of it. Okay, so it's pure open source, Apache 2, pure open source. So once we start an open source project, we start to see industry has interest in it, and then there are more and more people joining the project, and there are more and more people getting interested into it. So we realize, well, we cannot do this just with the open source project. We have to incorporate. We have to do a business about it. Otherwise, there's no way for us to really get the project to a level or get our work to a level that we think 𝗘𝗄𝗃𝗃 library can truly become. So that's the beginning of the company and the idea of doing a business around 𝗘𝗃𝗃𝗃, even though not many people were talking about 𝗘𝗃𝗃𝗃 back then, and even investors at back then 2 years ago didn't even know what 𝗘𝗃𝗃𝗃 is. They asked me, 𝗘𝗃𝗃𝗃, what is 𝗘𝗃𝗃𝗃? Is that real cash? So that was the beginning, and me and my co-founders, two of my students, 𝗃𝗃𝗁 and 𝗃𝗂𝗃, they were first developers, the core developers of this open source project, and they also saw the same vision to push this barely a temporary data structure in large language model to become the, like you said, AI's big data layer, and that's where we're doing now.
Awesome, such a journey. By the way, and back to 𝗘𝗃𝗃𝗃, the term, the origin of the term 𝗘𝗃𝗃𝗃, Junchen. I heard there's actually a bit of a background story behind the term 𝗘𝗃𝗃 itself. Is it true, correct me if I'm wrong, that in the early days, the research community made it a sort of a taboo-ish when submitting papers? Seems like they weren't really fans of the term. Could you tell us more about that background story?
Well, I won't say it's a taboo, but and that's a very strong word. But I think 𝗘𝗃𝗃𝗃 is one of many topics that in the history of computer science, the concept itself has a very humble beginning. 𝗘𝗃𝗃𝗃 is just a very one of many data structures maintained by a large language model during its inference process. It's the temporary data, the temporary state the model needs to maintain during its inference. It's something that only exists in GPU memory, and is also discarded after every query finishes. So naturally, when we started looking at this problem and want to write papers about 𝗘𝗃𝗃𝗃 itself, or optimizing the 𝗘𝗃𝗃𝗃 itself, or even build a system around 𝗘𝗃𝗃𝗃, there's a natural worry, or the concern was, the students thought, well, if we put 𝗘𝗃𝗃𝗃𝗃 in the paper title, will people recognize the importance of the paper, right? We may as well just say accelerating inference of large language models, or making inference more efficient. But actually, we will regret not putting the 𝗘𝗃𝗃𝗃 term in the paper titles in early days, because nowadays become a very popular term. Everyone recognizes the importance of 𝗘𝗃𝗃𝗃. So I think this is one of many terms in history where it's a technical term. It start as a very secondary concept in a bigger system, but the importance grow just dramatically over time, and people realize that is the most important piece. 𝗘𝗃𝗃𝗃 certainly has that quality, and I would say, just extending on that question, one of the reasons the industry didn't pay enough attention about this was because it's also part of the inference engine's internal data structure, right? And so not many people can even see it. Yeah. Okay, it's a variable. It's elusive. In millions of Python code, right? And that small data structure is now becoming the most important thing, and we're really happy that now we have the 3 years in research and engineering to produce something that people can use.
Yeah, that's insane. And it's an insane story, by the way, and everybody knows, mostly everybody knows 𝗘𝗃𝗃𝗃 today, right? But can we call 𝗘𝗃𝗃𝗃 context, or maybe what other word or term would you use to define 𝗘𝗃𝗃𝗃 for people that are not maybe from University of Chicago or PhD
Academia.
degrees? Yes,
right.
For like a layman or your future customers that are not into AI much research.
Certainly, 𝗘𝗃𝗃𝗃, cache is it's an acceleration technique, right? So it's a very technical term, but cache has the same pronunciation as cache.
Yes.
So a lot of people did pronounce 𝗘𝗍𝗃 as 𝗘𝗍$.
Yes.
But again, it's still technical because and we do want a better name for 𝗘𝗍𝗃. I don't want to blame people, but machine learning researchers certainly screw things up. But when they call it 𝗘𝗍𝗃, it's not really KV store type of thing. It's just two tensors, key tensor and a value tensor, just two tensors.
Value.
Exactly. There's just two 3D tensors. And now, but what's more important about 𝗘𝗍𝗃 it's not human readable. When I call it context, right? Context is text or a book or even programs, right? Or videos, images. These are context, but context and by natural human readable. There's something human can understand and put in the model's input. 𝗘𝗍𝗃 is model's digested version of knowledge.
Machine
so it's more native to models. So I would say more like AI native data or model native data.
Or internal memory.
Yeah, internal memory.
Okay, we'll go with internal memory then. That's easier for me at least.
Great.
Speaking of context, by the way, it feels like day one of AI was all about training frontier models without really thinking about the cost, where we just threw GPUs at the clusters and in order to train our models. But then what's the day two AI problem companies are facing today with inference? And also what did LMCache and Tensormesh cover as the real bottleneck?
I'm so glad you asked this question this way because there has been a trajectory of where the bottleneck is over the years. At the beginning, of course, this is training. And to be honest, when we started writing 𝗘𝗍𝗃 related papers, people thought we were optimizing training because that's the only thing people think are worth optimizing. Okay. But these days, certainly, inference has taken over training as the most expensive, if not most important part. Now, if you talk about inference, what is a bottleneck in inference, right? There is this misconception in the engineering world that inference seems to be bottlenecked by decoding or generation of the output. Certainly, there's some truth to it because the model does spend more than 90% of time decoding its output, for example, right? So perceptually, that is the bulk of the time the model spends on. But if you look at the actual GPU compute cycles, where in the inference process the GPU spend most of its cycles on, it is the preview. It is a preview where the model reads its input, including the context. And as people want the model to read more and more context to generate better quality output, the model will spend more and more its cycles in the context, in processing the context. The technical term is called preview. So you can see this. You have this very interesting contrast where people believe models are spending 90% of time decoding its output, but the models are actually spending 90% of the GPU cycles processing the input. And that's the hidden problem and the hidden bottleneck, the real bottleneck of inference. Now, if you think about reading the input as the bottleneck, and it's certainly true in many applications these days, reprocessing the same context is very common. And that's obviously a waste of GPU cycles.
Yeah, same prompts.
Exactly. Same system prompt or same images being analyzed multiple times or same documents being used used as the context to answer different questions. Or people, Cloud Code, of course, use the same code as context to generate more stuff. So repetitively processing the context is wasted. And what we want to do is allowing the model to remember its knowledge, the knowledge in those reused context. And the way to remember that is by keeping the KB cache in the system. That's what LMCache project originally about.
I see. So it's no longer a goldfish.
No.
It has memory. The other impressive thing we noticed since the inception of LMCache open source project is the consistent growth. You guys are closing up to 10,000 stars in barely 2 years. What did you do to keep the community so thriving and sustain the momentum?
Oh, I would say nothing.
Wow.
Because, well, obviously I'm half joking because the engineers and team and the contributors are working super hard to make sure the project move forward smoothly and pass all the CI/CD tests, right? It's stable. But I would say the biggest driving force of a project, open source project, is its community momentum. The community momentum really depends on the source of the momentum. Is whether the problem itself is important. Just like a product, right? The best product sells itself, right? Best open source project keeps the momentum from the importance of the project problem itself. So we feel really lucky to stumble on a problem very early on, that we believe would become the most important problem in the world, and it is slowly getting there, and we can see more and more contributors coming in to make sure that the open source project can fit their needs, because more and more people start to realize that they need a better and better 𝗘𝗍cache library in their systems, in their product.
True. I see. And now I'd like to switch gears now toward product evolution, because obviously you're a startup and you have production-ready solutions. And then you probably have a variety of solutions to these inference challenges on many fronts. This week, you also launched the V1 of the Tensormesh Inference Platform with serverless tier. So first of all, congrats. And could you tell us more about what this release unlocks for your users comparing to vanilla inference platform?
First of all, the Tensormesh V1 inference platform is a great way for ourselves to validate that our technology is not just an open source project, it is something that is production ready. That is our first test ground of all the best technologies we have. But at the same time, it's really the great way for everyone to test their workload and to see the effect of our best technology on their workload, how they can speed up their inference, how they can make their token bills cheaper. And I'm very glad to say that in our platform, all the cache tokens will be $0.
It's free?
It's free. And
Interesting.
the fraction of cache tokens is more than a lot of competitors.
Wow. So that means that everything that is being used in terms of 𝗘𝗍cache is not actually, there's no charging fees for that.
Yeah, it's free for the cache.
It's free cache.
Yes.
Good to know. Good to know. But beyond the hosted platform, you do have a solution for teams running AI infrastructure in their own premises. What can you tell us about this brand new suites of products that you guys still offer to these other teams that actually run AI in their own environment or other clouds?
You're right. So we have been working on the technology, a product that people can deploy directly in their inference cluster, not necessarily in our platform, but in their own platform. And this has been a focus of our open source project, our product team for a while. And then we have design partners from multiple places, key industry players to work with us on this. And although it's not announced yet, but I think that's our next step, where our best technology will not be just available through a GitHub repo or through a serverless API from our platform, but will be a product that people can deploy smoothly, transparently in their inference cluster to reduce their GPU cost and reduce their inference delay at the same time.
Interesting. So you'll be available everywhere.
Yeah.
Basically.
Yeah. That's the whole idea of 𝗘𝗍cache being the ubiquitous layer of all inference clusters.
Interesting indeed. Junchen, the more I hear you talk about 𝗘𝗍𝗃 so far in this interview, the more it seems that it sits almost at the center of every LLM architecture today or every transformer model. Could you explain what makes LMCache so agnostic and able to work horizontally across GPUs, inference engines, even storage vendors, actually?
The nature of 𝗘𝗍𝗃 is that it's only, it really is a part of large language model itself. So from that point of view, it should be independent to the hardware, the storage. What exactly is the storage to store that data structure? What is the inference engine that generates that data structure? And also, what is the GPU that creates the data structure? Right. So naturally, a good 𝗘𝗍𝗃 library should work with all these vendors and the systems. Certainly, that's the goal, and I would say the devil's in the detail, because having an open source project that can work with all these vendors is super, super challenging. And I would say so far we're still working on that problem, and we're probably ahead of many of our competitors in this area. But it's a very challenging problem. Fortunately, we have a lot of vendors, partners, collaborators from these companies to work with us to make sure that our library has a smooth integration with all their products, and the users of these vendors can readily use our library in their systems.
Fascinating. Speaking of vendors, by the way, you probably had to work a lot with hardware vendors early on. Could you tell us a bit about how you engage with them, and maybe how some of those relationships evolved into actual contributors to the project?
It's a very interesting question. If you asked me this question 2 years ago, I wouldn't have any answer to that. My background is in academia. I was in research, and all people I deal with are academia, right? And my PhD students, at best researchers from industry.
Sure.
I don't know how to talk to storage vendors.
Yeah.
We don't share the language, right? So at the beginning, there was not much interaction between these storage vendors, I would say, because when they want this technology, they talk in a different language. We don't share language. But interestingly, when we open source the project, open source projects attracted a lot of contributors from these storage industry vendors, and their engineers talk the same language with us because it's Python code, it's CUDA code, it's ROCm code, right? So it's just code. So when they start contributing to our project, we start to know, oh, that's what you want. Oh, that's the requirement of your hardware. Exactly. So we start to realize, okay, so here is something the industry wants to have. We gradually form an interface between the library and different storage backend, what we call storage backend vendors, and also the interface between us and the processors. So these things happen, I would say, mostly organically. But sometimes some industry partners, they're execs, they're the executive people. They see this very early on. For example, NVIDIA have some people really interested in this very early on. So some of the collaborations are also top down. So it's a mix, but it's also a fascinating experience for a researcher like me.
It must have been very interesting for you. Interesting. Now, there's one topic we can't actually avoid today, which is agents. So with the agentic harnesses completely changing the way inference and even tokens are actually consumed today, especially with sub-agent swarms and all their long contexts, where do you see Tensormesh fitting into the next generation of this AI stack? Is it good for LMCache, by the way?
First of all, it is an excellent fit for any 𝗘𝗍𝗃 libraries, to be honest. we see many vendors either using or reselling LMCache. They fell really hitting the jackpot when agentic application became popular. We certainly feel the same thing because all of our benchmark these days were based on either simple or complex agentic workflows.
Mm-hmm.
So why agent applications are a good fit for this?
Mm-hmm.
It really boils down to the fact that context is getting more and more important to large language models' performance. So at the beginning, when people started doing agentic development or agent harnesses back then, it was not called agent harnesses back then. It's just called tool calling.
Yeah, tool calling, of course,
and
with JSON files.
People thought, maybe large language model will degrade it to the secondary, just a mere component of a bigger system.
Mm-hmm.
Most of the intelligence will be from the tool callings. And then people realized every time you call a tool's output will be processed by the large language model, right? So over the life cycle of an agentic application, there will be more and more information, aggregated information, accumulated over the whole process, and all this information needs to be processed by a large language model. And that's why it's called preview earlier.
Yeah.
And that preview phase becomes more and more heavy. More and more GPU cycles need to put on will be spent on the preview part. However, if you realize, the reason model need to read more context during the agentic workflow is because it has to repetitively refresh its memory about this agent.
Yeah, that goldfish.
Exactly. It's a model is stateless. Model only knows the training data, knowledge in the training data, right? For it to process any information coming from the agent need to refresh its memory all the time, and that's repetitively processing the same context.
Yeah.
So 𝗘𝗍𝗃 will be a very handy tool for all agentic applications or agentic service providers to reduce its token bills, to even reduce its inference delay if they do it right. And certainly through LMCache, they can achieve those goals.
Yeah, because it's actually nowadays with the agents, it can go exponential. The load would just go exponential.
Exactly.
That's what would you say would lead to an explosion of the attention?
Explosion of the attention, and the 𝗘𝗃𝗃 being its representative or its semantic representation of 𝗘𝗃𝗃, it will explode as well.
I see.
You will see an explosion of cache.
Not the one with the dollar sign. Maybe both, actually, because they're related. Now, I'd like to talk about another thing that every startup has to face in their lifetime, which is fundraising, whether you like it or not. Some don't like it much. But one thing that stood out to us with this round is that a lot of your investors are deeply connected to the GPU industry and AI clouds. We got names like NVIDIA, AMD, CoreWeave Cloud. What does that alignment represent, or what does that alignment tells you?
First of all, I'm very fortunate to have investment from some of the institutional VCs, including Laude, which led our previous round, and Valley Capital this round. And they gave a lot of very good advice in shaping the direction of the company, and also open source project, because they have tons of experience in that. And that's why also we choose to work with them more closely. But at the same time, like you said, this round also attract a lot of interest from industry partners, especially processor vendors, GPU vendors, and storage and inference vendors. And I think that the fact that both inference providers and GPU manufacturers, including both AMD and NVIDIA, in this round speaks to the fact that this technology sits in the intersection between all these hardware vendors, because they realize this piece is the key to unlock their potential. Right? This piece is not just merely an acceleration for a certain model, it's the acceleration, the secret to accelerate every model And it's the secret to unlock the full potential of all their hardware.
The silver bullet against the bottleneck.
Exactly.
Interesting. All right, 𝗘𝗄𝗽𝗲. And before wrapping up this interview, Junchen, is there anything you want to leave the audience with? What should the viewers know that maybe hasn't been shared today about Tensormesh or the project, or simply where do we go from here?
Well, if I were to leave a few more words about where we are going,
Future.
First of all, in 10 years, I would say, probably in 5 years, I would say not many people will remember LMCache anymore.
Really?
They will not, because we firmly believe this technology will become an integrated part of every inference system in the whole world. LMCache is just the beginning of the whole revolution. Okay. For example, do you remember what's the first open source project of email system?
No.
No one knows. No one remember that, right?
No.
It's so everyday life right now. And do you still remember the first video encoding project?
No.
No, right? So it's so part of everyday's life. So I would say 𝗘𝗃𝗃𝗃 will become part of that, and LMCache being the first open source project, and probably right now the most popular open source project on this topic, may not be remembered in the future. However, I would say the best day of 𝗘𝗃𝗃𝗃, this concept itself, is yet to come. So far, everyone has been thinking about 𝗘𝗃𝗃𝗃 as a sort of black box data. It's just like a file stored somewhere. They think, okay, the inference engine create a 𝗘𝗃𝗃𝗃. I need to store it. Okay, store it somewhere, and then fetch it later. But 𝗘𝗃𝗃𝗃 is more than that. People didn't realize the full potential of 𝗘𝗃𝗃𝗃 because they saw it different. They saw it in the wrong way. 𝗘𝗃𝗃𝗃 is not just a file. It's not just some reusable tensor binary. It is the model's internal memory. Okay, these tensors really encode which tokens models are paying more or less attention to. These tensors really encode what the models, what connections the model sees between tokens in its input and output, right? If you want to know which part of the input really contribute to the output of this token, 𝗘𝗃𝗃𝗃 can tell you. So I would say it will be really a waste of its potential to just keep 𝗘𝗃𝗃𝗃 around as black box data. Now, not very proper analogy would be, you have kids and you're fascinated by their behavior. You see they approach the table and avoid it because they're smart. But it would be infinitely more interesting to see how they see the world. Right? And 𝗘𝗃𝗃𝗃 is the key to understand how the model sees the world. They're not black box to people anymore. They can tell you why the model, or at least potential to tell you why the model generates certain things. What is the input that affects its output? That to us is the most exciting bit of 𝗘𝗃𝗃𝗃. It's not money. It's not just something you can save money from, right? It's the key information to unlock models' potential.
I see. Incredible tech. So I would say it would mean that with 𝗘𝗃𝗃𝗃 you'd see the world through the lens of every model.
Yes.
That's a
great way to put it.
Interesting. And just to rephrase what you were saying, I've been actually thinking while you were answering the question about the fact that LMCache wouldn't be remembered, or that the details wouldn't be remembered. I think it reminds me of maybe a metaphor, maybe about, for example, today nobody says combustion engine. They just say engine. And it makes me think of that kind of metaphor where everyone today, if it becomes so present in anybody's life, people wouldn't need to call it or name it.
Exactly.
Because it's part of the environment already.
You put it better than I did.
Oh, no. I was just trying to decipher your cache. Well, Junchen, it was a pleasure to have you. Congratulations again to you and the whole team. We're so excited. We're all excited to see what's next for Tensormesh, and good luck. And thanks again.
Thanks, 𝗘𝗅𝗻. Very nice to be here.
Appreciate it. Thank you.